Hi, today we're going to be talking about the angular momentum of spinning wheels and how that affects the steering of motorcycles. Most motorcyclists use a technique called counter-steering when they are turning at high speeds. Counter-steering is where, in order to turn a certain direction, you have to steer the opposite direction. This sounds counterintuitive, but with the help of physics, we will be explaining why this works. The wheels of a motorcycle that is moving forward have an angular acceleration of omega. If we look at a 2D diagram of a front wheel moving away from us, the top of the wheel will be going into the page and the bottom of the wheel will be moving out of the page. Using the right hand rule, if we wrap our fingers in the direction of omega, our thumb will be facing the direction of angular momentum, which is produced as a result of the turning of the wheel. In this case, the angular momentum L1 is pointing to the left. According to the rules of counter-steering, if we want to turn left, then we have to steer the bike to the right. This is the same as applying a force on the left handle into the page. This induces a torque, which is a cross product of the vector r and the force that we have applied. Using the right hand rule, we find that the direction of the torque is pointing downwards. This torque causes a change in angular momentum, delta L, which is in the same direction as the torque. This gives us a new angular momentum, which is the sum of delta L and the old L. The axes of the wheels are now facing the direction of the new angular momentum. This makes the wheels tilt to the left. So, instead of turning to the right, a right steer results in a left tilt. This tilt doesn't explain why the bike starts turning to the left. When the bike is upright, the center of mass is directly above the point of contact between the wheels and the rod. This means that there is no torque as a result of the force of gravity. However, once the bike tilts, the center of mass is no longer above the point of contact. As a result, the force of gravity starts to induce a torque on the wheels. If we use the right hand rule again for this case, we see that the torque is facing the direction opposite to which the wheel is traveling. As a result, delta L faces that direction, which results in the wheel turning to the left. The bike will keep on turning until the rider shifts their center of mass to be above the wheels again. To demonstrate this further, I'll make use of a flywheel. This setup is representative of a rider on a motorcycle. The wheel represents the motorcycle wheel, while the weight represents the rider. A setup like this where they are balanced is the same as if the motorcycle was straight and the center of mass of the rider was directly above the point of contact between the wheels and the rod. Moving the weight to either side will be the same as the rider offsetting their center of mass from the point of contact between the rod and the tires. To begin with, I will push the left side of the flywheel to mimic a right steer. From our calculations, we expect the flywheel to tilt left. Now if we pull it towards us, it should tilt right. To show the effect of a tilted driver, I will move the weight to one side. As you can see, the wheel starts to turn as a leaning rider would do. We can also see that increasing the tilt angle, which is the same as increasing the distance r, will increase the torque, thereby making a faster turn.
Thank you for watching.